Hello, everybody. So, we are going to do applications like this one today. Sometimes they'll give us a diagram, sometimes they won't. So, I'm going to do one with a diagram and one or two without to give you an idea how these problems work. So, our problem today, oh, and by the way, this is applications of the law of sines and the law of cosines. So, and you never know which one it is until you get into the problem. Okay? So, the highest bridge in the world is the bridge over the Royal Gorge of the Arkansas River in Colorado. Sidings to the same point at water level. So, this is a siding. They're standing at the end of the bridge here and they side it down to a point on the water level. Okay? Directly under the bridge are taken from each side of the 880-foot long bridge as indicated in the figure. How high is the bridge? So our goal is to find the height of the bridge. Now, we know the bridge is 880 feet. And if you can just look at the outside triangle, what we know is we know a side, we know an angle, and an angle. So this is an angle side angle situation. All right. So we know that we can use the law of sines. All right. But why are we using the law of sines? That's what we need to figure out now. So, and that's why this is an application problem. So when you look at this problem, what you really want to find is h, the height of the bridge above the water. Okay, and I know one thing, it's over 1,000 feet because I've been to this bridge. I've walked across this bridge about 10 years ago. And I've been to this bridge when I was a little kid as well because I lived in Colorado. So that's where I grew up. Anyway, we know it's law of sines will help us find stuff in the big triangle, but what we want to do is we want to find the height in one of the smaller triangles. So what that tells me is I don't know any of the lengths in the smaller triangle because I don't know if this height goes to the midpoint. And I'm pretty sure it doesn't because these two angles are different. So this is not an isosceles triangle. So I'm thinking through my geometry. So what that tells me is I need to find this side right here. And the reason I need to find that side, or I could have found this side over here. But the reason I need to find that side is that'll give me a side and an angle in the right triangle. And then I can use right triangle information to find the height. So that's the thinking through these problems that you need to do. It's not always automatic. Okay? So you want to think through it. So let's go ahead and do law of sines. I'm going to label some things. I'm going to call this A. This is side A. This is B. This is side B. This is C. And this is side C. So the thing I know is the C's. So the first thing is I can take 180 degrees minus 69.2 minus 65.5. And that will equal the measure of angle C, okay, which I need for my law of sines. So we can go ahead and do that right now. I would encourage you to follow along with a calculator. It's always a good thing. So we're doing the 180 minus 69.2 minus 65.5, and that's equal to 45.3. So now we can do the sine of angle C over side C, which we know, and we know angle B, and we want to find side B. So I'm going to do the sine of B over side B. B is what I want to find, and so now we can fill it in. So the sine of 45.3 degrees over 880 feet equals the sine of 69.2 degrees over B. And so we cross multiply and divide, and we'll get B equals 880 sine 69.2 divided by sine of 45.3. Now, you don't want to find these numbers early. You don't want to actually put this in your calculator until you write it like this, so that you avoid round off error, okay? So we'll shrink that just a little so we can write the answer to side B. And I'm going to go ahead and figure it out, and you should too. Make sure the mode on your calculator is degree mode, okay? Which mine is. So 880 sine 69.2. Divide that by the sine of 45.3. And that'll give us 1,157.4 feet. All right? And that's how long B is. So B is 1157.4. Okay, so now we need to do the rest of the problem, which is the right triangle. So I'll draw the right triangle. Put 1157.4, and A, we'll call this M, this is C, and now I need to find the height. So I know angle A is 65.5, and this is the hypotenuse, and I want to find the opposite. So I'm going to take the sine of angle A equals opposite over hypotenuse, which will give me the sine of 65.5 equals h over 1157.4. Now, if you want to be more accurate in your answer, this is not a final answer. So I could put the decimal places here, 0.353973, like that. And what that'll do is that'll eliminate some of my round off error, okay? And that's actually a very helpful thing to do. So we'll cross multiply, and so we basically get the 1157.4, which I'm going to enter as what I got on my calculator, times the sine of 65.5 equals the height, okay? Now, actually, this number is on my calculator. So if I hit times sine 65.5, it takes the answer I previously got and just multiplies it. So I'll have no round off error now. Okay? I multiply that and I get 1,053.1 feet is the height. And this is our final answer. Okay? Now notice it's a two-step problem. This is what applications are. You got to think them through, and often you'll do one thing and it leads to a whole nother type of problem. Alrighty? So here's our next problem. It says Pat needs to determine the height of a tree before cutting it down to be sure it will not fall on a nearby fence. The angle of elevation of the tree. So let's create a tree right here. All right, we'll make it a redwood, right? Where it's got a long trunk. And then here's our flat path. All right, it says the angle of elevation of the tree from one position on a flat path to the tree is 30 degrees. So we'll draw that, and this is 30 degrees. This is an angle of elevation, okay? And from a second position, 40 feet further. So you go further, and then we get a 20-degree angle. What is the height of the tree? So we're trying to find the height, okay? Now, here's the trick on this problem. Much like the last problem, we see we have a right angle here, but we do not know any of the sides of these other two sides, so we can use right triangle trigonometry to find the height. So what we do is we go to the second triangle. Okay, the second triangle. You following my lightsaber? All right. That triangle, we know a side and an angle. And if we could find another angle, then, or another side, we could use the law of sines. Well, it turns out we know this angle right here. This angle right here is supplementary to the 30-degree angle, so it's 120 degrees. So if I go about and I label, we'll call this A, this B, and this C, then I can see that I have an angle, side, angle situation. Angle, side, angle. That means I can use law of sines. All right. Now, once I know that, I know the third angle as well, the one opposite the 40 feet. That's going to be 180 minus 120 minus 20, which is equal to 180 minus 140, or 40 degrees, and that's the measure of angle C. So we can put 40 degrees up there. So now we know all three angles. This is definitely a law of sines problem, so we can proceed forward. Now, the side I would like to find would be this side right here. So this is opposite angle B, so I would like to find side B. I know both pieces of information with side C, so the law of sines, the portion I'm going to use is sine C over C equals sine B over B. Like that. I can fill that in. So that'll be the sine of 40 degrees over 40 feet equals the sine of 20 degrees over B. Cross multiplying and dividing, and you get B equals 40 sine of 20 over sine of 40. So side B is equal to, and now I'm going to do my calculator. Actually, let's see if we're going to squeeze this down a little more, and let's make this slightly fancier here. Let's use the browser. And, okay, yeah, we can use the Desmos Scientific Calculator, okay? And if you'll remember, this was 40. Oh, there we go. I shrunk it now. 40 sine of 20. Okay, 40 sine 20. It's in degree mode, so I'm good there. Divided by the sine of 40 degrees. All right? And there's our answer. It's 20 point, let's make this a little bigger. It's 21.2835545 degrees, or excuse me, feet. So let's write that down, 21.28. Whoops. So I'll go back to writing it. So 21.28. Now that is B, so this is 21.28. Okay? Now, and we can't go further on the calculator, but there's showing you a calculator from Desmos, and we'll come back to that in a moment. Now, the next thing we need to do is now we know the hypotenuse in the right triangle, and we want the opposite side. So we can set that up as the sine of 30 degrees equals the opposite over the hypotenuse, 21.28. Now, that goes on and on, 3555, ... that goes on and on and on as a decimal. Now, if I was using Desmos Scientific Calculator, or I'm using my TI calculator, which is what I use, and so let me get this number on my calculator. Okay, so on my TI calculator, what I want to do to solve this problem is take the 21.28 sine of 30, but I don't want to introduce more round off error where I start getting more and more decimal places away from the actual answer. So on the Desmos calculator, what you would do is you would click this arrow, and that would give you a blank, and then you would click answer right here, and that answer would pop up, and it would just say answer, but it would be 21.28355555045, whatever it is, however many decimal places are there, it would put that there. On a TI calculator, I just press enter and it pops up, or I just press times sine of 30 degrees, and it says answer times that. And what I end up with then is 10.64, in this case, feet, is equal to the height of the tree. So it wasn't really a very tall tree you wanted to cut down. But that is a very typical problem, and one where you end up solving the outside triangle for a missing side or an angle by law of sines or law of cosines, and then the next triangle you have happens to be a right triangle, which you need to deal with. Okay? Anyway, I don't think I would have worried about a 10-foot tree breaking my fence. Those usually aren't too tough. Now, if it had been a 60-foot tree, then I would have worried about it, especially if you fell any trees in your yards before. Anyway, let's move on. Next problem. So I want you to try and draw this picture. We have an airplane flying due north from Fort Myers to Sarasota, a distance of 150 miles. And then it turns through an angle of 50 degrees and flies to Orlando, a distance of 100 miles. So can you go ahead and draw that triangle? Pause the video, draw what you're looking at, and then we'll talk about it. All right. Okay, it looks like you're back now, so let's look at this picture. Here's what I would do. I would go north, straight north, like that. Oh, let's make it a little shorter than that. Sorry about that. There we go. I'd go straight north, and this is from Fort Myers to Sarasota. Then at Sarasota, what do? I turn and I fly to Orlando. Now, how much do I turn? Well, I turned 50 degrees. So I turned 50 degrees, and then I flew to Orlando, okay? And then to finish the triangle, I could connect those like this, okay? So we've labeled S, O, and FM. So this will be side FM, this will be side O, and this will be side S. Okay? And then the only angle we have is this 50 degrees here. Now, what we learned is Fort Myers to Sarasota is 150 miles. What we also learned is Sarasota to Orlando is 100 miles. And we know this angle here that we turned is 50, so the angle supplementary is 130. Okay? Now, how far is it from Fort Myers to Orlando? So they want us to find the side S. So we have S, F, and O, and this is a side angle side problem. So since it's side angle side, we're going to use law of cosines. Okay? So that's going to be S squared is equal to, because I want to solve for S, F squared plus O squared minus 2FO cosine of S. Cosine of our angle S, which is 130. So S squared equals F squared, which is 100 squared, plus O squared, which is 150 squared, minus 2FO. So 100 times 150 is 15,000, and if you double that, you get 30,000. And then cosine of 130 degrees. Okay? So let's figure out the right side, and then we'll take the square root. All right? So we're going to take 100 squared plus 150 squared, and we're going to subtract 30,000 cosine of 130 degrees. Make sure your calculator is in degree mode, and we get S squared equals 51,783.62829, etc. Now, S squared, I'm just going to take the square root of that. So I do second square root, second answer. So I'm using this answer from my calculator and just taking the square root of this number. If I round it off, I'll introduce round off error. But if I go square root answer, then it'll use all the decimal places and I won't have round off error. So once I do that, I get 227.6 miles approximately. Okay? And so S is 227.6. So how far is it from Fort Myers to Orlando? We have now found that solution. Now, it says, what angle should the pilot use to fly directly from Fort Myers to Orlando? So what we want to do is we want to find this angle here, angle FM, okay? And so that now becomes a law of sines because we now know all three sides. And so this could be thought of as an angle side-side with one solution. And so we can do that. And so let's go ahead and do that. So I'm going to take the sine of F over little f, and I want to find big F here, Fort Myers angle. And we'll take that times the other part of this, the sine of S over little s. And what does that give us? That gives us the sine of F, the one we want to find, over F, which it was 100 miles, okay? And that's equal to the sine of S, which is the sine of 130 degrees, over 227.6. Okay? So we can use that one, or we could use the, well, that's the only angle we know. We only know this angle, so we have to use that one. Now again, on my calculator, I have 227.560161. So I can use answer for my last option, and it'll plug that in for the answer. As long as I don't do anything in between, I can use my previous answer. So what'll happen? We will cross multiply and divide, and here's what we'll end up with. We'll end up with the sine of f is equal to 100 sine 130 over the 227.6. Again, that's going to be answer on my calculator. Okay? So I'm going to do that first. So I do that first. So I do 100 sine 130. All right. And then I divide by answer. All right. Which is the 227.6 from earlier, but all the decimal places. So I get a number. So I now get the sine of f equals 0.3366 and goes on forever. Okay? Now, to finish that, I get f equals the inverse sine of this 0.3366. Now, this is the one you don't want to round off. You definitely want to use the answer key again, and I'll show you this on Desmos as well. I'll show you on the Desmos scientific calculator how I did these calculations here. And then, so we'll do second inverse sine of the answer, which was the 0.33. That was my last answer. And I end up getting 19.7 degrees. And I can round that off approximately. Okay, 19.7 degrees. And so that'll be this angle right here. And there's your two answers for this problem. Okay, let's look at this on Desmos. Okay, so let's go back. Let's go to my browser. Let's grab the Desmos scientific calculator. So what would these calculations look like? So the first one I did was the calculation to find the side that we were looking for, the distance from Fort Myers to Orlando. And so I entered 100, I should be able to square. Yeah, there we go. Oops, let's go back. 100, oops. Now I gotta delete. There we go. There we go. 100 squared. Okay, plus 150 squared minus, and I just figured this out in my head, but you could write 2 times 100 times 150, but minus 30,000 cosine of 130 degrees. Okay? And as you see, we get 51,783, just what we got before. So now I do that, and so then I wanted to take the square root of that, so I go square root answer. And so when I hit the answer key, it flashes it up there, and then I click, and that's how I got the 227.6. And then I went to the next problem, and that was 100 sine of 130 degrees. and then we had to divide that by the 227 by the answer. And that gave me the 0.3366. And then we take the inverse sign of that answer. And the inverse sign of that is the 19.67. Now, this is the way it works on every calculator. Okay? Knowing how to use the answer key so I don't get round off error. Now, just so you know, watch what happens if I round off along the way. So suppose I take the square root of 51,783.6 because I rounded off, right? So that still gives me 227.56. So then I do the, okay, but notice it starts to change out here. It goes 0, so we're okay to the 1,000th, but then things start to change, all right? So then we take 100 sine 130 sine 130, and then we divide that by 227.6, so we round off again. Now notice that gives 0.3365, not 66. Starting to change, the numbers are getting closer and closer, all right? And then we take the inverse sign of, and we round that off to say 0.34. Oops. All right. And if we do that, and then notice we get 19.87. So what I've done is I've compounded my round off error by rounding off in each step. If I round off in each step, then the final answer ends up being off. So traditionally in mathematics, you're considered correct on a calculator answer if the answer is 19.67191955, so 19.67, then if you get 19.66 to 19.68, you are considered correct. So this answer, the 19.87, would be considered wrong, even though you're 2/10 off, just 2/10, about 2.5 tenths actually. And so this is one of the things you really want to you want to learn how to use that answer key on your calculator. It'll really, really help you, okay? So just to wrap up, we did a law of sines and a law of cosines application today. Basically, it's the same kind of problems you've been doing, except now we have sort of some practical measurements that we would expect to see in our problems, okay? Now, how can you do this for real? So what would happen for real? I do want to give you a quick example of that in terms of what's real. And so let me shrink this up here, move this up here, and I want to talk about a real application. I did not see this in your lessons, but it is called bearing. And so if you have a compass, okay, and we label the compass like normal, okay, and then we do that Sarasota problem again, okay? Let's talk Sarasota. So what happens? We let Fort Myers be right here at the origin, and we went, boom, we went up 150 miles, okay? Then what happened? we turned. And they said a turn of 50 degrees. But what they could have said is they could have said the plane turned bearing north 50 degrees east. So what that means is you would go north, but then you would turn 50 degrees in the east direction. Okay? So north 50 degrees east puts the 50 right there. Okay? And then what did we do? We went 100 miles to Orlando. All right? Then when we did the problem and we wanted to find this angle, what angle do you have to turn? The angle we found was 19.7. So typically we would write our answer as north 19.7 degrees to the east. Okay? And so this would have been the heading that you would have done. Okay? And so bearings or headings, this is kind of the beginnings of navigation. Beginnings of navigation. And navigation is a real application of law of sines and law of cosines. Now, much of the work can be done on a computer, just like we did much of our calculations on a calculator. So you enter the information and then it figures out the stuff and it tells you what bearing or what heading to take. But notice you could also talk about, north 45 degrees west or south 10 degrees west. Okay? And putting these directional headings, north or east, kind of tells you which way to turn the angle for the terminal side of the angle. All right? So I wanted to give you this because most trig textbooks ask these kinds of problems, but your text did not, or at least I haven't seen any yet. So I just want you to be aware of this in case it shows up. All righty, that's it for today. Bye-bye.